Good morning and welcome to another industry-focused Fortress Machinery safety webinar. Today we're going to take a look at safe access to packaging machinery and have a deeper dive probably into palletising within that. We're going to keep it brief to the point and even attempt to entertain as we continue our bid to be marginally better than Rip Off Britain that's currently on BBC One. And you don't even have to pay a licence fee for this webinar. Your presenter today is Eve Edwards, our standard specialist. And Jordan Salmon and I, Malcolm Sharp, will be chipping in and generally messing all the tech up for you. We've already had major problems today, you'll be pleased to know. Use the Q&A function to ask any questions. It's at the bottom of the screen on the Zoom program you have. Please use that rather than the chat function for Q&A. It makes it easier for us to see them. We'll try and get to all the questions in the Q&A session at the end. If we can't get to your question, we will respond offline. We have some prizes to give away as usual, and we're going to have a one-question shootout at the end. Eve and Jordan are going to tell you all about the prizes later, but as usual, every expense will have been spared. It is Fortress, of course. And enough from me. Let's hand you over to Eve.
Yes, thank you very much, Malcolm. Hopefully my internet will survive the next 30 minutes. So it'll be about 30 minutes of a little bit of standards info and quite a few different applications, different ways of providing some safety solutions on some packaging machines. And then afterwards we'll take any questions and have potentially the potential to win some prizes. So this first slide is probably the most exciting one of the lot. It's your list of standards that are relevant in this space. So on the left, you've got your general kind of general standards. So that's your risk assessment, your prevention of unexpected startup, interlocking devices, and then if it's relevant, safety related parts of control systems. So that's PLs and categories and things like that. We have previously done webinars on almost all of those, or they've been referenced in kind of everything we've done, because they're relevant to pretty much everything. Also, by the way, the AS numbers are Australian standards left over from this morning, so you're only looking at ISO and EN, assuming you're in the UK or Europe right now. And then those EN 415 series, those are specifically for packaging machines, all different types of packaging machines, and those are really good for giving you lists of where to look for hazards in specific machines, where there might be hazards you might have not thought of, and then ways of reducing those hazards and reducing the risks associated with them. Those standards, I believe, are actually all being rewritten at the moment, but they're still very relevant as they are, and when they do get re-released possibly in the next year or so, then we'll of course let you know and bring you up to date. So you'll be glad to know I'm not going to go through every single one of those standards in detail, but this is just kind of list of things that come up in all or most of them, of things to consider when you're safeguarding your packaging machinery. So first thing to consider, and is mentioned a lot, is make sure that if possible, you just eliminate the hazard by design. So that's following the hazard control hierarchy, which you'll see in ISO 12100, where the most important thing to consider is, can you actually remove the risk completely? So can you remove that crushing hazard? Can you make it less by using less pressure? Can you remove that entanglement hazard by not having a rotating shaft sticking out of a machine? Things like that. Can you just eliminate the hazard completely? If not, then you go down the hazard control hierarchy and we'll use engineering controls like guards and interlocks and things like that. And that's what we're mostly going to be talking about. And if there's still any risk left, then that's where you use administrative controls, where you're going to be using things like flashing lights and PPE and training and things like that, where you've got to still rely on people. Next one is to consider all energy types. Remember that it's not just electrical energy. There can be kind of stored mechanical energy left over even after things have been turned off. There also can be pneumatic and hydraulic. A lot of packaging machinery does use airlines and things like that, and they also need to be considered because they can cause serious injury as well. Feed in and out as small as possible comes up a lot and is relevant in packaging because often there's going to be a conveyor in and there may be some pallets coming out or something like that. And it basically means if you've only got cans going in on a conveyor, don't have a conveyor that's big enough that a person can fit through, because all you're doing is opening yourself up to having more opportunities for people to be in dangerous situations. So keep those entrances into the dangerous area as small as possible, depending on what you've got to go in. And there's ways of doing that with pallets as well, where you have kind of a corridor and there's always a full pallet in that corridor, which stops people being able to come back up. And there's some really interesting applications that they suggest in some of the standards as well. Consider the environment. If it's very dusty, if there's possibility of maybe you're pressurizing vessels to fill them with things, maybe watch out for exploding jars and bottles. The guards need to be able to resist that if it's likely to have an explosion. Do you need hygienic things in food processing or things like that? Is there a wash down procedure in that area? Do you need things that can deal with that? And then finally, it's considering zones, because again, often in packaging and going between different areas where maybe you're putting on primary, secondary and tertiary packaging all kind of in a row. And in that case, you need to consider, for example, an emergency stop button in a certain place. Does that need to stop the entire factory? Does that need to stop one particular machine? What happens at the intersection between those machines? Are you going to cause another hazard? If you turn off one thing, is everything going to come flying off a conveyor somewhere else? So considering zones, especially in large operations where things are linked together, is really important as well. So we're mostly talking about palletizers in this. It just happened that they seem to be kind of across a broader range. Almost every factory has a palletizer or a depalletizer, which can kind of have exactly the same hazards usually. So a lot of that's going to be what we look at. That's EN 415-4, I think. And pretty much the suggestion is, if you can't eliminate the risk completely, then you can use fixed guards. Obviously, fixed guards are great if you don't need to ever get in the area, but that's fairly unlikely. So in which case, you're going to want interlocked movable guards. And they say that you should be at least a category 1 interlock system. If there's a risk of severe harm, then you're going to want something with a higher performance level, maybe a higher category as well. Or you can also additionally use electrosensitive protective devices. So that's going to be things like light curtains. That's going to be things like maybe radar sensors, laser scanners to detect presence of people where they shouldn't be, or detect presence and make sure that nothing's turned on while they're inside. The other thing that I wanted to point out, which I think is an important thing, is that the access of personnel should, if possible, be not the same place that the goods are going in and out. So it shouldn't be encouraged to go into an area along a conveyor or in through a gap that should only be used for the goods either coming in or out on their new pallet. And if you do have to use those areas, then you obviously will have to use interlocking or electrosensitive protective devices. But really you should use separate gates, because it's much easier to monitor whether a person is going through, or basically separate where it is, and it's much easier to monitor kind of the right thing, either a person or a item is going through the right place. So that was a useful point to make. And so I just, with the next few examples, we're now going to move into mostly just examples, are going to be using trapped key. And for those of you who haven't maybe come across it before, I'm sorry to those who this is very familiar, but it's always useful to have a refresher. Pretty much the very basics of trapped key is that you can have a switch here, which has a key trapped in it while it's on. So when this switch is turned on, so this is linked into the control system of the machine, the machine is on, you cannot remove that key. If you turn the key, it will turn it off, and that will then, when it's turned off, you can remove the key. You can then use that key, put it into a door lock. So if we go just back, this is on the door, this actuator is holding shut this door and it's locked closed. You can't open it when there's no key. If you take the key out of here and put it in here, you can then open the gate, sorry. And when the actuator is removed, so the door is open at this point with no actuator, you cannot remove this key. And obviously if you can't remove the key, then you can't turn the machine back on, because there's only one key, and it's either that the machine is on or the door is open, and you cannot have both happening at the same time. That's kind of the principle of trapped key, and you could use this to enter into a small hatch maybe, or something like that on a machine. And then Malcolm now is going to just talk through what you'd do in addition if you wanted, if you needed whole body access where you're going fully inside an area, and what that means.
Thank you very much, Eve. Yes, I get to do this again. If you've been to some of our webinars of late, you'll probably have seen what I'm about to present. We think it's really important, and it is relevant to virtually, well, every industry. Plus the fact I get repeat fees as well as a new fee for this gig today. So whole body access, not currently defined in any ISO machinery safety standard, which took me by a lot of surprise. It was last year when I found that out. And as technical committees, we are now trying to work together to make sure that it is defined across all of the ISO machine safety standards. So the point that we go to first really relates to the size of, I guess, access points in guarding through which a human body may pass. In fact, there is the gaps through which human body may pass in ISO 13857, which I think is also being rewritten at the moment. And it defines those gaps first up as a slot at 180 millimeters. Where we're really looking at whole body access is really around openings at 240 millimeters. And then I think the barriers are, of course, we have our typical beer bottle in there. If you are using a beer bottle as your rule, you need a Heineken bottle for that 24 millimeters. The Australians are particularly good at this, but do struggle because they have something called a stubby, which is a bit shorter than that. And they genuinely do use beer bottles as a unit of measure. So whilst that helps us define whether a person can get inside an area, what it doesn't really do is protect the person inside that area. And when we talk about whole body access, we're really talking about protecting the person entering the safeguarded space. And that brings us on to another subject that, again, we've covered previously, but again, super, super important. Proactive inhibit functions, reactive inhibit functions. When we talk about proactive, we are talking about measures that really put the safety of an individual entering the safeguarded space into their hands. And we obviously like to talk about trapped key systems because that's one of the ways of doing it. But when someone takes a safety key inside a safeguarded space, it prevents anyone else from restarting the machine behind them. Keyed reset systems, same sort of thing. So you might have a push button restart button that is key operated using something similar to like a house key. If the operator has that with them, no one else can restart the machine. Another one would be what we call an interlock blocking device. Eve will talk a little bit about that later. But an interlock blocking device, top left picture there, shows a facility padlocked in place that prevents an actuator being reinserted into the lock to allow the machine to restart. These are not currently covered in international standards. They are coming in the ISOs. They come from US standards. They're coming in the ISOs. Reactive is really, it's kind of too late if you're looking at reactive inhibit functions. The classic one in the list there is the internal opening device, often referred to as an escape release in ISO 14119. If someone is using that, something bad's happened. They're already trapped inside that area. So it's important to note that distinction between proactive and reactive as inhibit functions. And watch out for that in the next version of ISO 14119. I think it will also turn up in ISO 11161, which is integrated manufacturing, but will become integrated machinery. And if we move on, we'll have a quick look at that safety key that I talked about. And Eve does a wonderful thing with the cursor here to make sure, keep me on track so I know what I'm talking about. But if we look at the key switch on the left there, that would normally be wired into the safety related part of the control system. Turning and removing the key would issue a stop command. That key is taken to the first lock portion shown on the access lock, inserted and turned. Only then can the second key be removed, and that key is taken inside the safeguarded space by the operator, and it guarantees their safety. So no one can restart the machine behind them. It's old technology, but it's appearing more and more in modern standards today because it is such a good proactive inhibit function. And we'll have another quick look at an example of an installation that just veers off into another topic that is worth considering. This is an excellent example of an installation that also reduces the motivation to defeat, or takes away some of that motivation to defeat. You can see that the door lock is mounted behind the door itself, so there's no access to the actuator or the head of the interlock whilst the door is closed. It's quite often said that, oh, you can't do that with trap key interlocks because people see that you have access to the keys, but in motivation to defeat, more often than not, it's the actuator and people carrying spare actuators that become the issue. So this was a great example from one of our customers in the US, I think on the west coast of the US. So I thought we'd just cover that off. And before we move on to one final point that we hear a lot about, and that's, well, I've got a safety key, but my operators aren't pulling the key out. And that has been raised several times in North America, to the extent that we've developed something called the forced extraction safety key, often known as the extracted key adapter. But you can see we have something there, we call it a hairband, but it's like a metal clip that drops down over the lock whilst the key isn't in place, and can't drop down over the lock whilst the key is in place. And it's mechanically linked to our actuators, so that the band has to drop down before the actuator can be removed. And the only way that can happen is if the key is removed. It's innovative thinking that comes off the back of customers in America saying, can you have a spring-loaded key that pops the key out? Well, rather than just take that as a problem and try and solve it that way, it was, what do you really want to do? Make sure the operator has the key. This is a way of doing it. And on that note, I think we've got a video coming up that Eve's just going to talk through that demonstrates that.
Yeah, absolutely. And this just here is a sneak preview of one of my later slides, by the way, on a different way of using forced extraction safety keys. So this video here, if I can get it to play, is, I think it might, I actually can't remember, it is, it's a bottling plant. And what they're going to show is you take that key out and then you see that band falls down over here, and at that point you can open the gate, and underneath there's also a switch which is linked into the safety related part of the control system. And what they're going to show you here is the fact that while he is holding that key, he's taken it with him, he's closed the door. However, because he's holding that key, the reset function is not going to work while he's holding that key. And then he'll go back, put the key back in, lifting that hairband up, turn the key, and then the reset function now will work, and you'll see everything start to move once they've pressed the right button. I think they pressed the wrong button there. Yeah, and then everything starts to move again there. So that there's a switch in there as well. So that's mounting everything on the gate directly with a switch and a safety key, which is performing exactly the same function as that previous thing where you had a switch in a control panel and then a safety key on the gate. So that's just showing that kind of in action. I also wanted to mention that safety keys are not limited just to physical gates, but actually can be used on light curtains, or as some people might call it, a light gate. It doesn't have to be a physical gate. In this situation, there's a light curtain across here, and across here they're identical mirrored things. And on the control panel, using that's T-guard there, the control panel on the side, they were previously going in through the light curtain, and then obviously it would turn off the robot, go to a safe state, and that was fine. But what happened was there was someone kind of crouching down doing some work, maybe behind the conveyor. Someone walked past, thought the machine was just down for no reason, turned it back on, and I think the person got away with it, but could have had a very nasty interaction with a robot moving quite quickly. So what they now have is safety keys on the panel outside, so you can request to enter, remove the safety key, and once that safety key has been released, the light curtain is shut down, and the machine cannot be reset, the light curtain can't be reset, and the robot can't be turned back on until the safety key is back in. So it's exactly the same premise, but just with a light curtain instead of a kind of physical gate. So just wanted to make that you aware of that as well. And then finally, on kind of safety keys, is this interlock blocking device that was on that forced extraction safety key slide. So this is actually a product that we're bringing out kind of imminently. And basically it's kind of to retrofit a safety key. So if you've already got your interlocks on the door, be that kind of guard locking interlocks or just a non-contact interlock, any kind of interlock that's already on the gate, but you maybe don't have safety keys and you would want them, then this can be added in, and basically it will stop the door being fully opened. It can be opened far enough to break the contacts in the interlock, so the machine will be shut down by that separate interlock, but you cannot open the door properly because of this plate here until that key has been removed. When the key has been removed, you can then, this plate will fall down and you can open the door. But as you'll see from the back view, another plate will pop up as that plate comes down, and that will then stop it being closed again. So what that's doing is it will stop the door from being fully closed, and therefore stop the interlock from contacts from making, and stop the machine being able to be restarted until that key is back in, and until the key is back in and trapped. So while you're holding that key, you are safe from the machine being reset, and that's that proactive inhibit function of you're stopping the machine from being reset while you're holding that key. And there's also the ability to add in padlocks there. And as I mentioned, you can use safety keys with light curtains as well. There is a version of this also being developed where instead of it blocking a gate, it's blocking a light curtain. And so the light curtain is permanently broken until you return that key. So it's performing that safety key function with a light curtain as well. So another reason that you might, another thing that you might need to do other than just kind of isolating and then accessing is you may need to use mode selection. And this is a quote from one of those EN standards on packaging machines, and is talking about using key operated switches or a trapped key exchange system for changing the mode of operation. So rather than just always having to switch off fully, often with things like conveyors and some packaging machines of different types, you may need to put it into a kind of maintenance mode or a cleaning mode, and in that you're going to need to be able to maybe move at a slow speed. Conveyors are very difficult to get to if they go through a tunnel and they're not moving. You may need it to run at a slow speed while you're inside, or you may need to have a teach function or a jog function or anything like that. And it's recommended that a key operated switch or a full trapped key system is used for that. And you can see that here, there's that's a key, it's a switch with a key exchange on the front, and then those keys are released after switching the mode and used to open hatches as required in that mode. This thing here I want to talk about because you can see here there's a solenoid guard locking gate switch here. There's some push buttons here, and there are 3 safety keys here. And this kind of came about in all different boxes, taking up rather a lot of space because they were kind of specified by different people, and it's just the way it came about. However, if you wanted to have all of these functionality, you can actually put those into one neat unit here. You can have your extracted safety key at top, 2 further safety keys. You can have those buttons and that solenoid guard locking gate switch. You could also always, in the same kind of amount of real estate, put a lot more bells and whistles on. You can have RFID readers, you can have ergonomic handles with escape release on the back, you can have Ethernet connectivity, and all those things in that same unit. So it's just kind of considering the functionality and how much you need and what it can fit into. Taking this unit or something very similar to it, we have an example where one of our customers actually had a promotional video that showed perfectly the functionality of our units, so stolen a few screenshots from that. You'll see the units here on each of the gates, and then it goes through showing you what the machine does. It's filling boxes with products. So if you need to get in for maintenance or something's fallen off the conveyor or something, you can request to enter. This is a solenoid unit, so that goes through to the safety related part to control function. Once the machine is correctly shut down and in a safe state, this will then allow you to remove safety keys. You can take that safety key with you, open the door, wouldn't be able to open the door until that safety key's been released, and then perform whatever maintenance you need. So it's just showing how that's used, and then you'd obviously reverse that process and then press the other button to start the machine. So that's kind of that. And then I did very briefly mention an RFID reader, and you'd use that if in that example, I'm saying example a lot, if you only wanted certain people to be able to go in and perform that maintenance, so you didn't want anyone to be able to request to enter, although it would be safe for them to do so, it may not be very productive to have anyone who walks past being able to request to enter. So instead of a request to enter button, you can have an RFID reader. You can use your existing badge that employees are already wearing, and on the machine, press your badge on it, and it will either allow you to request to enter or not, depending on whether your name is authorized in the database that is on the system. So in that case, it goes exactly the same after that, but that request access is either approved or not approved before the machine is shut down. So if they're not approved, the machine won't be turned off, they won't be able to get in. Obviously, you can then use that data. You can see who's been going in where, how long for, whether certain machines are breaking down more often than others and needing maintenance. All different data can be logged from that, which is also really useful because you've got times and which door and all that kind of information can be used for anything that might be useful. You can also incorporate that same system with existing interlocks. So this is adding in that kind of request to enter thing. It doesn't even have to be a Fortress interlock that you're wiring to. Of course, we'd always say that it's recommended, but it genuinely can be used on third-party devices as well. So for that, you'd request entry by putting your badge on the reader. And if it was green, that would then tell the PLC that there's an authorized access request, and once the machine is then in its safe state, that would the solenoid would allow you then to enter through the gate. Again, if it was unauthorized, then the PLC would be left running as it was before and wouldn't shut down the machine or allow entry. It can also be used, that same solenoid unit, instead of opening the door directly, could release a key into a trapped key system. So again, it's just authorizing who's allowed to carry out that process. And then finally, it can also be used in place of the safety key. So instead of the safety key traveling into the area and then having to be brought back out again, and obviously to the same door, because it's a physical key, has to be put back in before you can lock the door again. It can actually be used as a kind of virtual safety key, where you'd be able to go in through one door and then out through another door, and it would know how many people and which people are in the area and when they've left the area, regardless of which door they go in and out of. So that's another really cool application for that. And I've gone just slightly over my 30 minutes, but I think we've pretty much made it. So if any questions have come in, I think Jordan was going to look through those.
Thanks so much, Eve. Sorry about that. For the first time in webinar history, me and Malcolm are in the same room. Can you hear an echo on your end, or is it okay?
Yeah, I've got an echo, so I think you've got both of your mics on.
Is that better?
That's much better, yeah.
Sorry about that. So as you can see, the technical difficulties of us both being in the same room have already tripped us up.
We did promise we'd mess the tech up.
Luckily, I don't need to be told twice to stay 2 meters away from Malcolm, so that's working in my favour. So we've got plenty of questions here to get through, and luckily for you, Eve, I think most of them Malcolm's happy to take. So first off, why are security screws not used for hidden trap key locks to prevent someone unscrewing the lock to gain access? Great question there, Malcolm.
Absolutely right, and I do have an answer. So currently, there is a small section in ISO 14119 on motivation to defeat. The current draft of that section has now expanded to be about 10% of the entire document, and it specifically covers the use of security screws and what screws can be used. So one of the screws we use for the lids of our products is, we call it a pinhead hex. So you have a kind of a hex point with a pin in the middle to make it and I'm using the inverted commas sign here with my fingers, a security screw. The new draft explicitly forbids the use of those screws because it's too easy for people to get hold of the drivers for them. So it talks a lot more about permanent fixing, about welding, and move away from screws. So actually mounting so people don't have access to the screws is probably the best means. A lot of work's gone into this. There's been a couple of German studies on motivation to defeat because of the number of accidents that have come from spare tongs and people removing screws. So it's a case of watching this space. But ISO 14119 is the standard to look for when it comes to interlocking devices, and to a certain extent light curtains as well, connected to the safety related part of a control system, which I think probably handles the second question on that subject as well.
Yeah, I think that's
so if anyone wants a copy of that draft, I'm happy to supply that. I do have copies. Email us, ask us in feedback, whatever. It'll give you an idea of what's coming up. We're about a year and a half, 2 years away from publication.
I can certainly attest to those screws not being secure anymore. My granddad used to show me with pride. He was a BT engineer, that he had all of the safety screws that he bought on the black market, so whenever he used to go into work, he wouldn't worry about it. Got another one here. Are safety relay keys available in ATEX variants for zone 1/2-21/22?
So for us, so there's a couple of ways around this. If you, and I'm guessing the person who asked the question may already know the answer on that, but or may have already considered this. We have two options. We do have some devices. We're currently developing our own ATEX approved devices, and they are, it will be called XGuard. It will be on the market probably sometime later this year. We also use a Honeywell variation as part of our products, and we can add safety key into that. And then there is the mechanical solution. So if you just if you mount the switch part, as we saw earlier with track key, you could take the switch part outside of the zone and only use the mechanical part within the zone. So there are a few options there, but the answer to the question is yes, we can help you out with that.
And then next up, I can take this very quick one. Yes, you will be receiving a copy of the slides after the webinar, and they will always also be on YouTube, so you can share it with your colleagues who weren't able to attend today. But also, there's a good question here for the Frank system that Eve was showing there at the end. Does the system require the same badge to be pressed against the reader in order to re-energize the system?
So I'm going to probably answer the question that's not been asked to start with, but we are kind of agnostic in terms of badges, so we can use existing badges. In terms of, I guess, controlling who can gain entry and who can't, that's going to be in the programming in terms of what the customer wants. But typically, if you have one person who needs to badge in and protect himself whilst inside the safeguarded space, they will need to use that same badge to restart the system. So that will comply then with current ISO 13849, and that technology will appear in ISO 11161, which will be called Safety of Integrated Machinery. It's currently Safety of Integrated Manufacturing. So yes, it does require the same badge.
Yeah, and I think as Eve mentioned, you can have several different access points and then badge out at a different access point to be able to move through those systems as well. That's also possible. And then finally, should the PLC be safety rated? I think that's referring to this Frank system as well.
And that is a great system. Whoever asked that question needs to join the committee for 11161, because that is a hot topic in that committee at the moment. What is a safety function? What isn't a safety function? Currently, that PLC is not carrying out a safety function as defined by 13849, safety related parts of a control system. So it is in addition, Frank is in addition to the safety that is being applied in that system. So your safety system will work exactly as it should do. This is an additional level of control over and above the safety. So the PLC sits outside of the safety related parts of the control system. So hopefully that answers the question. And happy to go into any of this at a deeper level. If people want to email in, you'll all get the email address when we email out the details of this webinar and the video and so on.
So just conscious for time, there's one last one that I think is a very quick one. Do you have the possibility of using fingerprint technology for access? I believe we're working on that.
So these are really, really good questions. So biometrics will be one of the things covered in the ISO 11161 standard. So essentially, if you look at that at the moment with the RFID card reader, it is just a request to enter. That could be biometrics, it could be a mechanical key. So yes, we're working on all that technology. And you will see this come out over the next couple of years from, I guess, multiple manufacturers. It is something that it provides this additional level of control to ensure the correct people are gaining entry safely. So yes is the answer.
And with that, should we go on to the tiebreaker question, Eve?
Yep, so I'm just going to do a quick plug for the after webinar survey, and that you will receive a machinery safety standards poster as a PDF and optionally in physical copy as well, if you'd like, if you fill in that webinar survey. So please do that, because it does really help us to know what to go forward and help us improve stuff. Suggestions and comments always welcome. And finally, this is your tiebreaker question to be in with a chance of winning a personally engraved Fortress key, which is has been highly coveted by a lot of people recently. And so if you answer in the chat, if you think you know the answer, and the question is a safety key used with a light curtain a proactive or reactive inhibit function? So if you think you know the answer, put it
we have some quick people there.
Chat, and you'll be in with the running to win one of those keys.
And obviously, just to let you know, we will put the answer to that question in the email that comes out after the webinar. So we've got a few coming in. I just want to say thank you very much for attending. We know there are plenty of other choices, although probably not BBC this morning. Daytime TV is looking a bit poor at the moment. So thank you very much from me, and I'm sure my colleagues will thank you too.
Yeah, I think one last thing to say is, even if you do not want one of those beautiful standards posters, please still do give us some feedback. The more negative comments about Malcolm Sharp there are, the faster we can get him off this panel, so we are appreciative of all those too.
With that, thank you very much for attending, and if there are any further questions, our email addresses will be in the post-webinar email, so feel free to get in touch.
Thanks very much.
Thank you, and goodbye.